In problem number 13 of the MSP practice test, it asked me to determine the measures of the interior angles of each interior angle, so each one of these angles in this regular pentagon. So what I want to know is what's the measure of that angle right there, or that angle, and they're all the same. There's 5 of them. And so one of the ways to determine that is to figure out what the sum of all the angles are together. And one of the ways to do that is to think of, if I were to cut this up into triangles, how many triangles can I make out of this shape? So we've got 1, 2, 3 triangles. And if you know anything about triangles, the sum of the angles measure of any triangle is 180 degrees. So this one is 180 degrees, and this one's 180 degrees, and this one's 180 degrees. In other words, if I measure that angle plus that angle, that angle plus that angle plus that angle, that'll be 180 degrees. And then that one plus that one plus that one's 180 degrees. And that one plus that one plus that one. They're all, anytime you take a triangle, you have 180 degrees. So if I take the total number of degrees of those, because all 3 of those together are going to add up to that angle, and all those 2 are going to add up to that angle, and those are, so all of these angles together are going to add up to the sum of the total angles in this shape altogether. So I just take that 180 times 3, I get the sum of all the angles of this, and so for a pentagon the sum of the angles is 540 degrees. Now it's not asking me the question of what's the sum of all the angles in this, it's asking me the measure of one angle in this. And so since there are 5 sides, or 5 angles, and the sum of them is 540, if I just take 540 divided by 5, then I will get the angle measure of each angle, which is 108 degrees. So each of these angles measures 108 degrees. And if you just knew that this was 540 degrees for this one, because you know the different shapes and their angle measures, then you could have just done that. But if you didn't, any shape that I have, like even if I just took a square, and you know those corners are all 90 degrees, but you also know that if you cut it into triangles, you'd have 180 and 180, which together makes 360, and 360 divided by 4 is 90. So there's your 490 degree angles. And if I had a 6-sided shape, let's do some other examples on here, just because this is a sample problem and chances are that's not going to be the one that you get on the test. But if I think of cutting this into triangles, so let's see, how many triangles do I have here? 1, 2, 3, 4 triangles, 180 degrees each. So if I take 180 degrees times 4, that makes 4 triangles. That's a total of 720 degrees for all the measures of all the angles inside that 6-sided figure called a hexagon. And if I took the 720 degrees divided by the 6 sides, there's 6 of them, 1, 2, 3, 4, 5, 6, and I take that 720 and divide it by 6, and I get the measure of each angle, which is 120 degrees. So I can do that with any shape. No matter how many sides it has, I can cut it up into triangles and figure out how many triangles there are. And because I know a triangle is 180 degrees, the angle measures, if I can't remember for any other sided figure, I can always divide it up into triangles, multiply by the number of triangles, and then divide by the number of sides or number of angles that shape has in it for any regular sort of polygon, regular shape. So that's a good example of using one method to solve for any shape at all. In this case of this one, it's 108 degrees. In the case of a square, they're 90. In the case of a hexagon, they're 120. And we could go on to 7-sided, 8-sided, however many sides, and use the same method to solve for any of those kinds of shapes.